When massive stars collapse at the end of their life cycle, a black hole is formed. But a neutron star is formed when the core of the giant star is collapsed. They are among the most bizarre objects in the universe. Now let's take a deep dive on how neutron star is formed and what they are. A giant star, which are about 4 to 8 times as massive as our sun, explode in supernova at the end of their life cycle. As a massive star dies, expelling most of the fusion blown into space, the star's core collapses to create the densest form of matter in the universe, called a neutron star. In neutron stars, the atoms have all collapsed. The electron clouds have all been sucked in and whole thing become a single entity with electrons running around side by side with protons and neutrons in a form of gas or fluid. Neutron stars are of city-sized, having radius starting from 10 kilometers. Despite their small diameters, neutron stars are 1.5 times heavier in the mass than our sun. It is so dense that a single teaspoon will weigh a billion tons, assuming we have taken sample from neutron star. If the core of the star has enough mass, then the gravitational collapse will continue and a black hole will form instead of neutron star. Now what is neutron star made up of? Inside the neutron stars, as per current thinking, there is a thin crust of iron, and under that the composition is largely neutrons. Neutron stars packs an extremely strong gravitational pull, much greater than Earth's. On average, gravity on neutron star is 2 billion times stronger than gravity on Earth. The average neutron star boasts a powerful magnetic field. Earth's magnetic field is around 1 Gauss, and the Sun's magnetic field is around few hundred Gauss according to astrophysicist Paul Sutter. But a neutron star has a trillion Gauss magnetic field. They have powerful and abnormal magnetic field known as magnetar. It is so strong that it can pull out the keys out of your pocket from as far away as the moon. And due to supernova, which causes neutron star to spin several times in a second, it can spin as fast as 43,000 times per minute, gradually slowing over time. A neutron star does not generate any light or heat of its own after its formation. Over millions of years, its latent heat will gradually cool from an initial 600,000 degrees Kelvin, eventually ending its life in the cold. Some neutron stars stream out jet of materials at nearly speed of light, and we can see them as fluctuating bulb. Scientists call them pulsars after their pulsing appearance. Although neutron stars were long predicted in astrophysical theory, it wasn't until 1967 when the first was discovered as a pulsar. Since then, hundreds more have been discovered, including the famous pulsar at the heart of the Crab Nebula. Even 2 neutron stars can orbit around each other, and when they are close enough, it can collapse in an intense phenomena known as kilonova. The collision of 2 neutron stars made waves heard around the world in 2017, when researchers detected gravitational waves and light coming from the phenomena. Research also provided the first solid evidence that neutron stars collision are the source of much of the universe's gold, platinum, and other heavy elements. There are estimated to be more than 100 million neutron stars in our Milky Way galaxy. The closest known neutron star is about 500 light years away. However, many will be old and cold, and therefore difficult to detect. A neutron star isn't as dense as black hole, but it's denser than any other known type of star. That's all guys, thanks for watching. If you like our video, give the thumbs up, consider subscribing, and see you next time.